This is the AI-powered robot I built to automatically shoot my phone out of my hands every time it catches me doom scrolling. In this video, I'll be showing you the process on how I built this robot, from the part selection to the electronics, the design, code, and at the end, we're gonna see if this robot can actually detect my phone and stop me from doom scrolling. Oh, and make sure to stay till the end, as I also programmed the robot to shoot at solo cups just to see how accurate it is. This project all started when I was in a cycle of doom scrolling Instagram reels, watching YouTube, playing Clash Royale, and losing to Expo decks. That's when it hit me. I needed to build a robot that would stop me from doom scrolling, inspired by something that really makes my blood boil. The Expo from Clash Royale. For those who don't know what an Expo is, it's pretty much a turret which can locate its targets and shoot arrows at them. So I set out to make an alternative version of this that shoots bouncy balls at incredibly high speeds, destroying anything in its path. For this project, all we're gonna need is a LiPo battery, 2 high RPM DC motors, 2 servo motors, a micro servo motor, a PCA driver board, some BTS motor drivers, an Arduino Uno, a web camera, a toggle 14 switch, 6 flywheel, a buck regulator, and 100 bouncy balls. Oh, and a bunch of random cables and screws to put it all together. Now, I'm no electrical expert, but this is the part of the project I was most nervous about, as if I even messed one thing up, I could potentially fry all the electronics I spent all my money on. Since I didn't know what I was doing, I started off by testing both the BTS and PCA driver modules. The BTS module is responsible for driving the DC motors, which act as the main launcher part of the robot. Meanwhile, the PCA controls the 2 servo motors, which acts as the left and right pan, as well as the up and down tilt. This is what's known as a pan tilt system. After confirming all of these boards were working correctly, I set out to connect the rest of the components up to the power supply. For this, I connected the battery to an infuse line, then to the power switch, and finally to a 1 to 3 pigtail converter. One of the outputs went to the buck regulator, which can then be used by the PCA module. Meanwhile, the 2 other outputs go to the high RPM DC motors through the BTS module we previously talked about. And with those up and running, I had all of the electronics complete. I'm not gonna lie, I was pretty surprised with how smoothly things were going, but it was time to get into the fun part, the design of the robot. So here it is in all its glory, and it kind of looks like a medieval torture device mixed with an elementary school slide. Actually, the final design doesn't even look like this, and the slide feature was actually meant to allow the balls to roll down into the launcher, but as soon as the robot tilts up, it no longer is able to roll down, so I had to completely redesign the launch ramp. And after a lot of design changes, here is what the actual final version looks like. Let's go over the design choices I made while I assembled the final robot. Starting with this big ass case. I had to make sure I had a neat way of keeping all the electronics hidden, and so I made sure to measure out carefully how big the base needed to be. Next, I printed the mount for one of the servo motors and attached it to the base. Remember the pan tilt system? Well, this is where the pan will go, and the tilt servo will be mounted to this left pillar here, like this. With the pan tilt system fully set up, I decided to stick my web camera to the base and give it a go with what I had so far. The panning communication was actually reversed, and instead of tracking me, it was moving away from me. I quickly made a few changes to the code, and to my surprise, everything was working perfectly up to this point. The robot was even tracking my uncle's bald head from across the room, which is pretty crazy. And if you're wondering how the code works, let me give you a quick 20-second breakdown. The webcam is directly connected to my computer, which is running a Python code with an AI image processing library called YOLO, which can detect objects such as my phone, the color red, and even my face. This information is then sent to the Arduino code, which is written in C++ and uses a bunch of already existing libraries to talk to the really fast spinning DC motor and the servo motor. Once the object is detected and centered, the trigger gate will open up and allow bouncy balls to release and fire at the target. I also wrote this manual script so that we can test out all the features and make sure everything is working properly. With all the code installed, it was time to finish up the final robot, and with all the quick success I'd been gaining, I was starting to feel invincible. But that's when the world shut my ego down, as the final 10% of this project was a literal nightmare. To start off, I tried to come up with an O-ring designed flywheel inspired by this YouTube video right here, but that wasn't working out. So I changed my design and mounted the motors to the robot, and that's when the launch ramp snapped. I buffed up the launch ramp, disassembled and reassembled various iterations of my flywheel, trying to find the perfect size, and this took me about 30 hours of work, until I finally got the balls to start launching out. Well, they were launching out, but they weren't going very fast, especially with how quickly and how powerful the motors were moving. That's when I realized the balls were actually all slightly different sizes. And so I worked another 20 plus hours trying to figure out what the perfect in-between would be. I finally got up to a speed where the bouncy balls would shoot straight across my entire house. Being able to manually launch the balls was cool and all, but I needed the robot to do this on its own. I first tested out the simple case, which was pushing one ball into the flywheels, but now I needed a way to hold multiple balls, so I 3D printed this little holster and I mounted that to the top. I then had this second micro servo to act as a blocking device so that the balls wouldn't all just fall through at once. Now with a little bit of code, I got it so that they were moving at the same time, and after literal blood, sweat, and tears put into this robot, it was time to test out the final product. Hey, if you're liking the video so far, this is my first ever upload on this channel, so make sure to subscribe and let's see if we can hit 10 subscribers by the next upload.
Finish him!
Alright, now we're gonna do the solo cup test. I've set up 15 solo cups and I have 15 bullets in the robot. Let's see how many cups it can knock down.
Double kill!
So, is this robot actually gonna stop me from going on my phone? Well, no, screw this thing. I'm literally never turning it on again.